Hey everyone, and welcome to The Explainer. Today, we are conducting a high-energy forensic engineering audit of some truly mind-blowing source material. We're going to unpack the exact analog mechanism that these documents claim was used to perfectly time the anti-gravity engine of the Alien Reproduction Vehicle, or ARV. We're talking about a machine that allegedly warps space-time itself. And to understand how it manages to do that without just tearing itself apart, we have to look really closely at its heartbeat.
Okay, let's just dive right into this with what sounds like an impossible engineering paradox. How on earth do you keep perfect time inside a million-volt lightning storm? When you're dealing with a flying machine that generates massive electromagnetic pulses, EMPs, the stakes couldn't possibly be higher. The timing of the engine must be absolute. But the crazy environment inside the craft would destroy literally any traditional clock.
Section 1. The anti-gravity engine. 48 slices of a million-volt pie. Let's get into it.
So, to understand why timing is literally everything here, we first need to understand the engine itself. According to the source material we're auditing today, the floor of the ARV is essentially a massive 48-segment pizza array. These individual slices are actually heavy capacitor plates made out of a specialized ceramic called barium titanate. The documents state that the ship creates a stable gravitational vortex by firing millions of volts of direct current right into these floor plates. And it does this in a rapid, continuous, rotating sequence. Basically, picture a terrifying high-voltage merry-go-round.
Now, what's really wild here is the absolute zero margin for error. If the timing of this rapidly rotating firing sequence is off by literally just a single microsecond, the results are catastrophic. The gravity field collapses asymmetrically, which means the lift just vanishes on one side of the craft. Instantly, this 30-ton ship flips upside down and drives itself right into the ground at Mach 5. So yeah, the firing rhythm must be flawlessly, perfectly consistent.
But here is the massive roadblock the engineers faced. You simply cannot use standard digital computer clocks or software algorithms to manage this firing sequence. Standard silicon clocks naturally drift over time. Software has glitches, right? It crashes. But the real killer? Pumping millions of volts into the floor thousands of times a second creates a localized EMP storm inside the hull. An EMP storm of that magnitude would instantly melt or freeze any normal silicon microchip.
Which brings us to Section 2, Lightning versus Thunder, escaping the speed of light.
To survive this apocalyptic electrical environment, the engineers had to completely abandon electricity for their timing circuits and turn to a brilliantly simple workaround. They had to look at the relationship between lightning and thunder. See, the core challenge was creating a perfect delay between firing one plate and the next, but electricity travels through a copper wire at roughly the speed of light. To delay an electrical firing signal by just 1 microsecond using a wire, you'd need to spool nearly 1,000 feet of copper wire between every single laser trigger. Packing 48,000 feet of wire into a small, shielded flight computer? Yeah, that's physically impossible.
So they use the physics of thunder to slow down the lightning. While electricity travels at blinding speed, we're talking around 186,000 miles per second, sound travels physically and way slower. Through a dense ceramic, sound moves at just about 3 miles per second. By abandoning electrons and switching to the sluggish, physical speed of sound, they literally found a way to delay the speed of light.
And this leads us straight to a crucial piece of analog technology from the 1950s, the acoustic delay line. By definition, this is a device that delays an electrical signal by converting it into a slower-moving physical sound wave, like an ultrasonic vibration. It sends that sound physically through a solid block of material and then converts it right back into an electrical spark at the other end. Grasping this specific mechanism is the absolute key to understanding the ARV's flight computer.
Moving on to Section 3, the barium titanate solution, the magic rock of the military-industrial complex.
And that brings us to the actual material that made all of this magic possible. Our audit identifies this specific lab-grown ceramic as the foundation of the whole acoustic hack. Barium titanate is a massive dielectric, which is really just a fancy way of saying it's an unbreakable electrical sponge. It can hold millions of volts without shattering. Crucially, it's also highly pielectric. That means when you shock it with electricity, it physically expands and vibrates, turning an electrical pulse directly into a physical sound wave. Plus, it's virtually indestructible under extreme aerospace stress, making it absolutely perfect for high-frequency oscillators.
Now, what's really amazing here is that the source documents trace an unclassified corporate patent trail proving this isn't science fiction. Defense contractors were perfecting this exact ceramic right at the dawn of the Cold War.
In 1947, we see the foundational high-K ceramic blueprint from the Titanium Alloy Manufacturing Company. By 1949, patents were filed for using it as a piezoelectrical oscillator. And then, in 1955, the critical breakthrough happened: barium titanate delay lines.
And folks, here is the smoking gun. Look at this quote from U.S. Patent 278243, granted to Bell Telephone Laboratories in 1955. It specifically notes that barium titanate delay lines precisely control the timing of high-frequency signals. They literally weaponized slow sound for exact microsecond timing right during the era these advanced craft were allegedly moving from the drawing board to testing.
Section 4. The Unbreakable Metronome. An analog clock made of rock.
Let's look at how this all comes together to form this completely unbreakable metronome. Inside the flight computer, there's what's called a physical ring counter. Picture a steampunk-style physical maze made up of 48 tiny barium titanate blocks. They act exactly like an endless, circular setup of dominoes. It's a fail-proof, hardware-based loop designed specifically to force those 48 lasers that trigger the engine to fire in a perfect sequence.
Let's break down this domino effect so it's super clear. First, the computer sends a master pulse that fires the initial laser. At that exact same moment, that electrical pulse enters a tiny barium titanate crystal block, instantly turning into a physical sound wave. That sound wave then physically travels the entire length of the block. Finally, once it reaches the far side, the crystal turns the sound back into an electrical spark, which fires the next laser. And the loop just continues. Perfectly.
The most important thing you should take away from this is how the timing is controlled. It isn't dictated by lines of vulnerable, buggy software code. It is dictated by the immutable, physical length of the rock itself. These crystals are machined by engineers to a mathematically perfect length, guaranteeing that the sound wave takes an exact, unvarying microsecond delay to reach the other side.
So, the huge takeaway here? There is zero code involved in the timing loop. There's no software to crash, no processor to freeze, and no operating system to glitch. Because the firing sequence is enforced by a literal physical maze of sound traveling through rock, the clock is 100% immune to the million-volt EMP lightning storm raging right outside the computer box.
Now, you might be asking, okay, if the timing is locked in stone, how does the pilot actually fly the ship? Well, it's surprisingly elegant. When the pilot steers, the computer simply changes the intensity of the laser flashes, say, hitting plates at the front of the ship with 5 million volts and plates at the rear with 1 million volts to tilt the gravity well. But the speed of the engine timing, that acoustic metronome never, ever changes. The heartbeat is absolute.
Let's quickly summarize the sheer brilliance we've unpacked here today. To pilot a gravity warping machine, these engineers solved a catastrophic EMP threat by completely abandoning digital clocks. They used the slow, physical speed of sound to perfectly delay the speed of light. They built an unbreakable metronome out of vibrating ceramic blocks. And in doing all of this, they seamlessly merged 1950s radar patents with cutting-edge 1980s aerospace engineering.
Which leaves us with one incredibly provocative thought to end our explainer today. If human engineers were able to master the physics of gravity and build an infallible flight computer using just 1950s acoustic science and vibrating rocks, what else is ticking away in the dark? Think about the implications of that for a second. Thanks for joining me for this engineering audit, and as always, keep your curiosity fired up.